Okay, this video we'll try to work on conversion of NFA to DFA. Now let us have an NFA where you have three states, Q0, Q1 and Q2. Let it move on different edges. So you have Q0, Q1, Q2. You have transitions from Q0 to Q1 on a transition to itself, a lambda transition, which makes it as an NFA, and then back to DFA. Now, the first step is we have to identify the DFA states, as well as we should decide on their transition. And therefore, the initial state of NFA will act as the initial state of DFA with we'll represent the DFA states within curly braces. So Q0 here is the initial state. Here we'll have Q0 within parentheses. Now the next step is to figure out what transitions we have from Q0. So when I say it, you will have two transitions. One is transition on A and the transition on B. If you check out, from A, you have transition on A to Q1. But what all strings should we check? We should check for A. We should check for A lambda. A preceded with any number of lambdas, and any number of lambdas succeeded with an A. So we have to check for three strings: A lambda, and lambda A. Lambdas can be of any number. So this Q0 will on A can lead to Q1, and by reading A lambda, it can reach Q2 also. Okay, so what happens? The output of A would be Q1 and Q2. And that is what we try to see here. It is you try to find the extended transition. Q0 on A will lead to Q1 and Q2. So Q1, Q2 becomes the next new state. What about transition on B? From Q0, I don't have any transition, and therefore we have a trap state on B. And then from Q0, Q0 is the first DFA state. From Q0, we have found out transitions both on A and B. A leads to a new set Q1, Q2, and B leads to a trap state. Now we'll move forward. Now from Q1, Q2, I have to check for one sec. From Q1, Q2, I have to check on A and as well as on B. Now Q1, it's like when I say Q1, Q2, how do I check it out? It's like delta star of Q1 on A separately and delta star of Q2 on A separately. Now what about Q1 on A? Q1 on A leads to Q1, right? Q1 on A leads to Q1. If you see here, Q1 on A leads to Q1 here, and Q1 on A will lead to A lambda leading to Q2. So Q1 on Q1 Q2 on A will lead to Q1 Q2 itself. So you have a transition to itself. Now what about B? When I say B, Q1 on lambda, it moves to Q2, and Q2 on B, it goes to Q0. So Q1 on lambda B leads to Q0. So now we'll go ahead with the next one. Q1 on B leads to Q0. Q2 on B also, you have a direct edge to Q0, and then you don't have any lambdas there. So you check only for lambda B and B alone. So it moves to Q0. So Q1, Q2 on A, you have Q1, Q2. Q1, Q2 on B, we move to Q0. Now the next question is, I haven't found any further transitions, right? There are no more transitions. Now you have A5 is a trap state. Now you have to check out which is the final state. The final state of NFA is Q1. All the states which has Q1 in the DFA set will act as a final state. Here Q0 alone is there, but here you have Q1 and Q2, where Q1 is a final state of NFA. Suppose if I have Q0, Q1, that acts as another final state of DFA. So here Q1, Q2 is the final state. So the initial state of NFA will act as the initial state of DFA. The NFA, the final state of NFA plays a role in deciding the final state of DFA. How does it happen? Wherever the final state of NFA is present, then we are going to have the final state of DFA. And this is how you try to translate it. Once this diagram is drawn, we'll directly go ahead with the drawing of the transition table. I think this procedure is clear to you so that you'll be able to understand the concept. We'll stop here.